There's something lurking at the edge of our solar system that astronomers have been hunting for decades. Not a planet, but something far more mysterious, a failed star known as a brown dwarf. This object may be orbiting our Sun at an incredible distance, so far away that it's remained hidden from our most powerful telescopes. This is the dark star theory, the idea that our Sun might be part of a binary system, with a much smaller, dimmer companion that has eluded detection. If it exists, this brown dwarf would be between 10 and 80 times the mass of Jupiter, too small to ignite like a true star, but far larger than any planet. The dark star would orbit our Sun at a staggering distance, potentially up to a light-year away, taking hundreds of thousands of years to complete a single orbit. At such extreme distances, even an object with significant mass would appear impossibly faint from Earth, making direct observation extraordinarily difficult. But if we can't see it, how do we know it might be there? This is where the story gets fascinating, and it begins with some of the strangest objects in our solar system. In 1983, NASA launched the Infrared Astronomical Satellite, IRAS, which detected several mysterious infrared sources that couldn't be easily explained. One of these objects, temporarily designated as Object X, appeared to be a massive body at the outer reaches of our solar system. The discovery made headlines, with the Washington Post running the title, "Mystery Heavenly Body Discovered," but further observations failed to confirm its existence. This wasn't the first time astronomers had proposed a distant companion to our Sun. In the 1980s, scientists Richard Muller and Daniel Whitmire suggested that a small companion star might explain periodic mass extinction events on Earth. They called this hypothetical object Nemesis, and proposed that its orbit might occasionally disturb the Oort cloud, the vast shell of icy objects surrounding our solar system, sending comets hurtling toward the inner planets. The Nemesis hypothesis has largely fallen out of favor, but the idea of a distant solar companion hasn't disappeared. Instead, it's evolved. One of the most compelling pieces of evidence for a distant massive object comes from the peculiar orbits of trans-Neptunian objects, or TNOs. These are icy bodies that orbit beyond Neptune in a region known as the Kuiper Belt. In 2016, astronomers Konstantin Batygin and Mike Brown noticed something strange about certain TNOs. They were clustered together in a way that seemed statistically unlikely to be random. While Batygin and Brown proposed a large planet, Planet 9, as the cause, other astronomers have suggested that a brown dwarf could explain these orbital anomalies just as effectively. A brown dwarf's greater mass would allow it to influence these distant objects even from much farther away. But what exactly is a brown dwarf? These objects exist in the gray area between planets and stars. They form like stars, from the collapse of a gas cloud, but don't have enough mass to sustain nuclear fusion of hydrogen in their cores. Instead, they briefly fuse deuterium, a heavier isotope of hydrogen, before cooling down over billions of years. Brown dwarfs emit most of their energy in the infrared spectrum rather than visible light, making them difficult to detect with conventional telescopes. The smallest and coolest brown dwarfs, classified as Y dwarfs, can have temperatures as low as 80 to 100 degrees Celsius, not much hotter than boiling water. This makes them nearly invisible in infrared wavelengths as well, especially at great distances. If our solar system does harbor a brown dwarf companion, it would likely be one of these ultra-cool white dwarfs, which is why it has remained hidden despite our increasingly sophisticated astronomical surveys. The existence of a dark star would fundamentally change our understanding of our solar system's formation. Most stars in our galaxy actually form in binary or multiple systems. Single stars like our Sun were thought to be the exception rather than the rule. Finding a distant companion would bring our solar system in line with this pattern. How might such a binary system have formed? Computer simulations suggest that during the solar system's birth about 4.6 billion years ago, the same cloud of gas and dust that formed our Sun could have created a second, smaller object. Gravitational interactions during the early chaotic period of planetary formation could have pushed this companion into an extremely distant orbit. Alternatively, our Sun and the dark star might have formed as a wide binary pair from the start. Some binary star systems have separations of more than a light-year, while still remaining gravitationally bound to each other. The implications of a dark star go beyond mere astronomical curiosity. Such an object would have a profound influence on the structure of the Oort cloud, the vast sphere of icy bodies that surrounds our solar system and extends halfway to the nearest star. The gravitational pull of a brown dwarf companion would reshape this cloud, potentially creating a bridge of cometary material between the two objects. This could explain another mystery, the origin of long-period comets. These icy visitors from the outer solar system often arrive on extremely elongated orbits that take them thousands or even millions of years to complete. Some arrive from directions that are difficult to explain with our current models of the Oort cloud. A dark star could provide the gravitational nudges needed to send these comets toward the inner solar system. But if this object exists, why haven't we found it yet? The search for distant solar system objects is extraordinarily difficult. Even with our most powerful telescopes, detecting a cool, dim object at such extreme distances requires both luck and persistence. The Wide Field Infrared Survey Explorer (WISE) mission, which operated from 2009 to 2011, was specifically designed to detect brown dwarfs. It discovered hundreds of them throughout our galaxy, but none appeared to be a companion to our Sun. However, WISE had limitations, particularly for detecting the coolest white dwarfs at great distances. The search continues with new tools. The James Webb Space Telescope, with its unprecedented infrared sensitivity, could potentially detect a distant brown dwarf companion if astronomers know where to look. The Vera C. Rubin Observatory, which began operations in 2025, will conduct a decade-long survey of the entire visible sky, creating a detailed time-lapse that might reveal the slow movement of a distant massive object. There's also the possibility that we've already detected the dark star without recognizing it. Astronomical catalogs contain millions of objects, and something moving as slowly as a distant brown dwarf might appear stationary over the time frames we've been observing. It might be hiding in plain sight, misclassified as a distant background object. Some researchers have even suggested looking for the dark star's gravitational influence on spacecraft leaving our solar system. NASA's Voyager and New Horizons probes are traveling into interstellar space, and slight deviations in their trajectories might reveal the pull of an unseen massive object. If confirmed, the dark star would join the growing list of paradigm-shifting discoveries that have reshaped our understanding of our cosmic neighborhood. Just as the discovery of Pluto in 1930 expanded our knowledge of the outer solar system, and the subsequent discovery of the Kuiper Belt in the 1990s revealed a whole new region of our planetary system, finding a brown dwarf companion would force us to redraw the map once again. The dark star theory reminds us that despite centuries of astronomical observations, our solar system still holds profound mysteries. We've mapped planets, moons, asteroids, and comets, but the vast darkness between stars may hide objects that challenge our understanding of our cosmic home. As our technology improves and our surveys of the sky become more comprehensive, we edge closer to either confirming or ruling out the existence of a dark star. Either outcome will deepen our understanding of how star systems form and evolve. The next time you look up at the night sky, remember that somewhere far beyond the visible planets, in the cold darkness of interstellar space, our Sun's mysterious companion might be silently orbiting, waiting to be discovered.